Hey everybody. Today, you can see the title on the screen. We're going to work our way through something that we'll refer to as some special products. That is, we've been building our way up, figuring out how we can do some extra multiplication with some algebraic expressions. Today, what we're going to address are maybe some patterns in some things that we may see that may fall into like the special kind of category. They're not rare, they're actually quite common. But they're just some things that you're going to see so often that maybe we can kind of put them into the, hey, I can remember how to deal with this column. Okay, let's jump right in. So what you see on the screen right now, there are three expressions that I would like you to simplify. This is going to fall into the, hey, check your understanding kind of category. So I'm hoping you can take a peek at those and notice that those have come from previous lessons and previous practice work. Let's see where we are with that previous material. So what I want you to do is tackle these ones on your own. We'll come back and we'll do a bit of a check to see how well we're doing. Okay? Pause the video now. Try them on your own. Okay, we're back. So for us to take a peek at A, we'll do a little confirmation. We should be good to take everything from one bracket and multiply it to everything in the other bracket. The pressure that I put on you previously was, when we see that pattern with the same variables, let's try not to spend our time expanding that into 4 terms. That if we can recognize that, hey, our middle terms are going to collect, then I'm hoping we're good on 3y squared. We recognize that we would get a minus 5y, then a plus 9y, so that is a positive 4 of them, and then finish off the expanding. So the goal is, can we get to that point where we are expanding in one term? In one line. So we can take a look at B. B, I should be good to be expand my first terms, and there's my 12a squared. I notice that I'm going to get a terms and a terms, so I've got 15 of them, minus 8 of them is a positive 7 of them, and then finish expanding. And we finish off on C. So we can take a peek and recognize that we have an 8x squared at the beginning. When we expand, we're going to get negative 36. We're going to get negative 6 more. That gets me to a negative 42. Those terms happen to be xy terms. And then I can finish my expanding. Okay, you take a peek on that screen, and I'm hoping that we're good, that we have the 3 gold solutions. If we're putting in that middle line, so take a look back at A, where I've got my pink and then my green line. If we're putting that in, I really want to challenge you. Try to expand and collect in one step. Okay, it's really going to help you out with where we go. Okay, let's change gears a little bit and still work through on some simplifying. So what I would like you to do is just take a look on the screen right now. I've now thrown up 5 expressions that some could consider special products. What I want you to do is just take a moment and examine those 5 to see if there's something kind of special in those 5 that maybe hasn't popped up so often. If you can come up with the pattern to that, then what we want to try to do is pattern out, well, what's the result when we simplify? Okay, you are noticing that pattern. I'm going to go ahead and I'm going to expand A pretty quickly. I'm hoping that we can take a peek, and if we were to simplify that first expression, I will do my multiply. I'll notice that I get a minus 4x plus 4x, and then I get my minus 16. I would love that. Love it. I'm going to go back, and I'm going to put in a previous line, though. That previous line may have been this. Now, I really, really hope that in our gold line, we didn't write plus 0x's minus 16. Because I hope we recognize that that's not simplified. If you're going to add in 0x's, then you're adding in 0. And then to physically write down plus 0 in an expression, is meaningless. It's a waste of your time. If it mattered, then I should just be able to write plus 0 plus 0 plus 0 at the end of every expression ever. And I'm hoping we can see that that is a waste. That adding in 0 does not change the value of the expression, so we don't write it. And so if I had to go back to that original, I now have my minus 16. We just notice that our middle terms canceled out. Okay, I think I'm going to have some of you that already see the pattern then. For others, I think it's going to take one more. Let's take a look at B. If I was to put in the long expanding, then I have a minus 5y and a plus 5y, and now my minus 25. We should see, hey, we got the same pattern again. My middle terms are going to cancel out, and that is going to get me my y squared minus 25. Okay, there are two things that I want to draw to your attention. First off, we need to recognize the pattern that we may have saw at the very beginning. And then secondly, we need to recognize what happens based on that pattern. So let's quickly scan all 5 problems as originally given. I'm going to box them in. I'm hoping that maybe the pattern we had was, hey, I have the same brackets that are being multiplied together with one exception. It's different signs in between my terms. Take a look at B. I have the same values inside my brackets, different terms. Different signs in between. And maybe you can see because of my pink line why that results in the pattern when we simplify. Okay, I want everybody to take a look at C, the expression in C. If I just focus in on the pattern, I have the same brackets multiplied together, except it's different signs in between. Well, what's the outcome when we expand? Well, I think everybody should be good on the a squared, but then we notice that when I multiply on those outsides, and when I multiply on the insides, I'm going to get the exact same term, but different signs. I get a plus 3a and a minus 3a. And if I get two of the exact same things, but opposite signs, then they will always cancel out when we collect. And so, I don't even have to worry about that. And I can simplify that down to the gold. Okay, I want to highlight a couple things. First off, what you have with those expressions is something that's referred to as conjugates. Conjugates are factors that, when multiplied, have different signs in between their terms. Same values, but different signs in between. And when we expand conjugates, when we actually do the multiply, then we get an expression called a difference. Now, I'm going to stop for a second on the difference. And all I want to do is I want to circle in green the operation in between your two terms. Notice it's subtraction. Subtraction is another way of saying difference, or difference is a way of saying subtraction. So notice when we expand those conjugates, we get a difference between those two terms. Also, I want you to notice what those two terms are. They are perfect squares. Look at the first term in each expression, and I'm going to argue to you, duh, they're a square, because look at the exponent on each of them. But now also take a look at the last term in each gold expression, and you'll notice that's a perfect square. Why? Because how did we get it? Well, look back in A. We got the 16 by 4 times 4. In B, how do we get the 25? 5 times 5. In C, how do we get the 9? 3 times 3. That value at the end is a square. Okay, I also want to draw to your attention a pattern that you did not see on previous days. That is, every time we were always expanding a binomial times a binomial, we got 3 terms. And now you notice we don't. We actually get 2 terms. And that's very important to us. That we actually want to put in our mind that when we expand brackets, we get a difference of squares, which is 2 terms. Sorry, when we expand conjugates, we get 2 terms. If we are expanding conjugates, we should expect to get 2 terms. Okay, I want everyone to focus in on D. If I was to take the long route, you would now be multiplying 2x times 2x. You would now write down your plus 2x and your minus 2x. And now you expand. So I want to highlight for you, if anybody thought that there was going to be something different in D, because we now had a number out in front of our x. We had a coefficient on our variable that wasn't 1. Hey, maybe the pattern changes. I'm hoping you can see the pattern doesn't change. My middle terms cancel out. And so what I would love for us to do as we take a look at problem E, I would love for us to recognize what's in front of us first and react, as opposed to blindly expanding all the time and then having to simplify. What I mean is, I would ideally love for you to take a look at the expression in E. 3x plus 2y times 3x minus 2y. And our first look go, hey, I've got opposite signs between the exact same terms. I have conjugates. And I know when I expand conjugates, I get a difference of squares. And so the only multiplying I'm going to do is 3x times 3x and 2y times 2y. The only thing I really need to focus in on is my expression is a difference of squares, and therefore I need to make sure that when I multiply my 2y times my negative 2y, that is a negative in between. Okay, what you see on your screen are 5 examples of us multiplying conjugates. I want us to get some extra practice dealing with those expressions. So we're going to see a bunch of those expressions in our daily practice. We want to get used to expanding those as a special product, just as we would any multiplication. Okay, I want to change gears now. Okay, so take a look at the screen that you have in front of you now, and I've given you the same instruction we've been working on, simplify. And I want you to take a look at the 2 expressions I've given you, okay, in A and in B. And I really want to kind of nail down the difference between those 2 expressions. So when we begin, I want to highlight that difference. And maybe you can notice that the base of my power, my squared, happens to be 1 term in A. It's all of 3a to the 4th. But then you might also notice that because I have that addition symbol in between the x and the 3, that I have 2 terms inside my brackets. So I want to come back to that aspect because the difference between one term versus two terms in my base changes everything. We tend to use the terminology that we would apply that exponent to all parts of the base in problem A. You saw problem A in grade 9. You would now apply that exponent, so you would square the 3 and square the a to the 4th. Again, you might think back to it as laws of exponents. On the a to the 4th, you would now be raising that to another exponent too, and so if you have a power raised to another exponent, you multiply the exponents. There's our green. However, when you take a look at B and you notice that you have two terms inside the brackets, that forces us to expand. And so we would have gone through and said, well, if I have my squared, I cannot just do this because that's applying the exponent. It's not expanding the brackets. So maybe what we do is we go, okay, let's imagine, I understand what a squared means. And so if it was x plus 3 squared, then that really just means x plus 3 times x plus 3, and you could turn it into a problem like you've already addressed. And then pretty quickly, and we will be better at this and not expand it to 4 terms, although I'm going to for this one. Expand that to an x squared plus 3x plus 9, and we clean that up, of course, to that pink expression. Okay, I want to highlight the difference between those two things and make sure that we are really, really clear. In green, we apply the exponent because the base of the power is one term. In blue, we expand the brackets because the base of that power is multiple terms. Okay, now what I want to do is I want to jump through one more problem. It's going to look just like B or very similar to it, but I want us to get a little bit better than what we just did in the pink. Okay. I want you to take a look at problem C, because I hope we recognize that problem C is like B. You see that minus in between your two terms, and you go, okay, so that means it's multiple terms. I need to expand my brackets, but what I want you to avoid is crossing out that bracket and writing it out again. That there is actually a pattern to going through and expanding that perfect square. And that pattern is going to be one that you are going to want to know. What we have in front of us is a perfect square binomial. You can see you have a binomial base because it's two terms, and obviously a perfect squared because of the squared. I could not repeat enough. Do not be satisfied by going, I know I could always just do that. Don't. With where you're about to go, you need to be able to recognize this pattern. So, we do not scratch out the exponent, write out another power, and expand. I am going to write out all 4 terms if we were to expand. So I want you to imagine that extra factor being there. We would have had our x squared. We would have had a minus 4x. We would have had another minus 4x. And we would have had our plus 16. Okay, ideally I would love you to imagine the pink. If we're struggling, I'm going to put it on. Now we should see where the pink comes from. But what I want to do is I want to highlight a pattern to you. If we can recognize the pink, then I think we should be good to keep the squared in there. I am going to put a little cross out through that pink because I want you to imagine it's not there, even though I'm going to talk about it as being there. Okay. If I recognize that I have a binomial denominator, then I need to expand my brackets. But my pattern to expand can recognize my squared. You can see we square the first thing. And you can see with your pink bracket why we're going to square the first term. Because when we expanded, we're going to get an x times an x, and that gives us an x squared. Okay, I'm going to get rid of that little highlight. Now, our middle term. I want you to look at my pink terms. Can you see that when I collect that, I will have a negative 8x? I'm going to get a negative 8 of them because I'm going to have two negative 4s. When I expand my brackets, look at my blue arrows. I will have a negative 4x, and then I'm going to have another negative 4x. That means whatever I expand, I'm going to get double of, because I got two of them because of the two brackets. Okay, let me get rid of those purple arrows now. Now, what can be my shortcut, my recognition of a pattern? Well, if I multiply the two parts of my base together, you'll notice there's my negative 4x. By multiplying those together, I get one of my middle terms. Now, I need to recognize that my pattern with this perfect square is going to give me two of those terms. So if I want to have my shortcut is going to be multiply the two inside terms together, following my blue arrows, and then double it. So multiply them together is a negative 4x, double it, negative 8x. And now I can finish off my pattern because I know I'm going to have to square the last term. I can see why I'm going to square it because I will have a negative 4 times a negative 4. And so when I square it, there is my positive 16. What I would love us to do is to work through using that pattern. Now, I'm going to put something up, and I really do not want you to spend any time trying to memorize this. I actually think it's a bad habit to get into. But if I gave you that expression, and maybe you can see once I get rid of all of that stuff at the top now, how x minus 4 all squared could take the form of like a plus b all squared. Something plus or minus something all squared. Well, if I was to expand my a plus b all squared, I would square the first thing, I would multiply those together and get an ab term, but then I have to double it because I'll have two of them, and then square the last. Sometimes people read that green, and then what they try to do is they try to memorize that form. I could not be more serious by saying I think that that is a waste of your time. Please don't. That is so abstract to you, it's going to make math about memorizing. Don't. Rather, let's keep using the pattern. So if I was to jump down all the way and tackle question C again, I see that I have to square x minus 4. So I square the first. I now multiply the two things inside together, and I get a negative 4x, double it, negative 8x, and now square the last, square the negative 4. There we go. Hopefully not too bad. That is a pattern that I would love for you to drill in, to make to the point where it's just an algorithm. We will see perfect square binomials so much that we really want to make it second nature that we can go through that pattern. So let's take a look at some additional problems. Okay, there's our 5 problems back up on the screen. What I want to do is I want to use these to nail out some common mistakes. That is, I want to go through and I want to simplify those 5 expressions just to give us some additional practice, but then also figure out where we are going to make our common mistake. Okay? What I would love you to do is to try just D right now. We're going to see if we have that pattern without looking it up, without rewinding back in the video. I want us to see if we've picked it up just from problem C. Okay, pause the video now. Okay, we're back. So, nobody is crossing out the 2 and writing another a plus 5 factor. We should be good to say, I'm going to square the first thing, so square the a, multiply those two values together. So, a times positive 5 is a positive 5a, but then I have to double it because I got 2 of them. Now finish it off. Square the last, and you are good. Okay, hopefully that one went well. What I want you to do, try the next 4. Okay, I want you to try the next 4. So let's try to do them on our own. Pause the video, and we'll see when we check back. Okay, pause it now. Okay, we are back. So hopefully question E went pretty well. We could square the first, multiply them together, double it, square the last. Okay, I'm really hoping that you do not have that green on your screen. However, that is a super common mistake, and let's really try to work through to not make that mistake. When I square 1, I do not get 2. Oops. Okay, there is my common mistake. Hopefully we got a 1. If we have the green, then I think we're picking up that pattern. If we goofed up, we made a mistake, figure out whether it was a silly mechanical mistake or figure out whether it was a theory thing. Maybe you have to pause the video and now try the next 3 on your own. Okay, I'm going to keep moving my way through F. What makes F a little different than all the other ones we've done? You might notice you have a coefficient on your variable that's not 1. Is that a difference? Yes. Is that a meaningful difference? I'm going to argue no. If I had to go through and I now expand that to simplify, I'm going to square the first. I'm hoping we came in there okay. If you went through and you said that your middle term was 6x, then we made a mistake in our algorithm. Can you please look back up to D and E? We made a mistake then that you thought that you double the last number, the last term. We don't do that. We first have to multiply the two things together inside the brackets. So you'll notice with that coefficient on my leading term, on my x term, it's going to change it a little bit. 2x times 3 is a 6x. Now that I double 6x, I should get my 12x. Then we can finish off with a 9. And if we matched up with that gold, then I think we're doing really well. Okay, take a look at G. When we expand G, I'm hoping we're good on the 4x squared. I think everybody should be okay to multiply those two things together and get a negative 10x. And so when we double it, we get a negative 20x. Where do I think your mistake is on this one? I think it's the green minus 25. Be very, very careful. And there's a little pattern here that we can use. Very rarely in math, like notice I had to say very rarely, but very rarely do we get always or never cases. This is an always case. So it's kind of nice when we get always situations. When I finish off to get my green term, I have to take that squared, that exponent 2, and apply it to my last term. That last term is negative 5. So when I square a negative 5, then I'm going to get a positive 25, not a negative 25. That is a super common mistake. Here's the nice part. Can you look back at the 4 gold solutions you have right now, and you'll notice every time I square, my last term has got to be positive. Always. So something that you could use then to help you out. Nice. Okay, we've got question H. I'm just going to slide up my screen a little bit and shrink it so we can get in a full solution for H. H should be our check. So if we went through, we squared the first term. We multiply those together, so that's going to give me a 6ab. Double it is a 12ab. And now we square the last, and there's my 4b squared. And if you came up with those gold expressions, then I think you are doing great. Nice. Okay, we've covered some differences of squares by multiplying conjugates. We've addressed some perfect square binomials. I think we're at a time now where we got to put all this stuff together and see how we can combine it with what we've done on previous days. So take a look at the screen that you see in front of you now, and you'll see 3 expressions that I'm asking you to go through and simplify. But those 3 are going to combine some of the stuff that we've talked about today and previous days. So what I want you to do with these 3 expressions, I want you to go through and try to simplify. Okay? What I want you to do, write it as if it was like a challenging evaluation, a challenging practice quiz. You give them a shot, see where your gut instinct takes you. We'll see how we match up in the end. Okay? Pause the video now. Okay, we're back. So I want to take a look at the expression in A, and we'll see how well we did. We've tackled A before, but it's been a bit. Then I'm hoping we took a look at A and we saw that we have a binomial, 2 things, times a trinomial, 3 things. And so when we methodically went through and expanded those brackets, 2 things times 3 things is going to give us 6 things. So hopefully when we took our time and expanded every part of the first factor into every part of the second factor, we were able to get our 6 terms. So I'm going to take that x and multiply it by everything, which is going to give me an x cubed, a 3x squared, and a 2x. I am then going to take that 2 and multiply it by everything, and there is my 2x squared, my 6x, and my 4. And when I multiply the 2 things times the 3 things, I have my 6 things, but there's a bunch of that stuff that's going to collect. So I have nothing to collect with my x cubed. I can put together my x squared terms. I can put together my single x terms, and I have my constant. Okay, nice. Hopefully we matched up with the gold, and if we did, then you've got some pretty good feedback that you're really flexible with being able to go through and expand. Nice. Okay, what I'm going to do is just maybe shift over problem B. I'm going to put a little wavy line in there just so we don't get confused with where A finishes off and B starts. Okay, let's take a look at B now. Well, I notice that I have 2 things times 2 things times 2 things, but I also notice I've got a triple product. Okay, well, if that is multiplied, then what I could do is I could multiply the first 2 binomials together, and I should be good that when I expand those binomials, I'm going to get a trinomial. So let's go ahead and do that. If I chose to multiply those first 2 things together, then there is my 2x squared. We should be working to be able to expand this in one step. So my outsides are going to give me a negative x, my inside's a positive 2x. So when I collect that, that's a plus 1x. And then I've got my minus 1. Now, be very careful. If I write down that multiply by the last factor, the 2x plus 1, that is actually incorrect because the only multiply that's on that page is my negative 1 times the 2x plus 1. When really what I need is the entire product, 2x squared plus x minus 1, to still be multiplied, which means I would need those brackets still around that trinomial. Okay, I'm hoping that you can take a look at that. And what you notice is if you chose to multiply that way, you just created a problem that looks an awful lot like A. So you could slowly and methodically go through and expand all parts of the first into the second, get your 6 terms, collect, and simplify. Okay, that's one way to go through. But I maybe want to talk to you about a better way. I want to look at that original expression for what it is. It's a triple product. It's something times something times something. So if instead of looking though at those like algebraic terms, like imagine I put a value to them. And I said like the first thing was 2 and the second one was 3 and the second one was 4. What that expression tells us is 2 times 3 times 4. And if I asked you to calculate 2 times 3 times 4, I don't know, what do? Do you do the 2 times 3 is 6 and then multiply that by 4 and you tell me 24. If you went 2 times 3 times 4 is 24, then you multiplied the first 2 together, then multiplied the third, you're doing the blue solution. But does it matter what order we multiply in? I hope the answer was no. That you may have chosen to go, well, 3 times 4 is 12. Then take that answer and multiply it by 2. And that's how you got your 24. Or maybe you took the 2 times the 4 times the 3. It doesn't matter the order. It doesn't matter when we multiply. So if you take a look at my green arrows, that may have been a better way. I'm going to pick the order I multiply that makes it easiest for me. Okay, I want to keep my blue solution there, but I want us to imagine that we didn't do that. So what I'm going to do is I'm just going to put a single line through that solution. It's there, but it's not there. And what I want to do is I want to erase my 24 up top, but I want us to be focused on how we could best multiply. I want you to take a look at all 3 of those binomials, and I am hoping that something is screaming at you. Do you notice that my last 2 binomials are conjugates? That can speed things up for me. Take a look at my blue solution. Again, it's not really there, but it's there. Notice when I chose to multiply my first 2 together, just did the multiplication in the order it was given, that created a trinomial, 3 terms. And if I am going to multiply 3 terms by 2 terms, then I'm going to get 6 terms. So I get a lot of terms, but they'll simplify. I'm going to guarantee to you that you are not that comfortable with that yet, just because it's new and you haven't done a bunch of practice on it. But take a look at what I just circled in red. We know from today's topic that when I expand conjugates that look like those, I don't get 3 terms. So if I can show some patience, or I pull the blinders off and I look at the problem and I say, hey, it's not good for me or the best for me to multiply the x plus 1 in yet. I'm going to save that out in front. I'm going to be patient because when I expand those 2 conjugates, my middle term is going to cancel out. And there's my difference of squares. You'll notice I only have 2 terms. And I would guarantee that everybody is better at expanding 2 terms times 2 terms, multiplying binomials, as opposed to having a trinomial in there. So we should be able to take that goal now and finish expanding pretty quickly. When I multiply, there is my 4x cubed. You could choose to end up getting like a minus x term here, but then my expression's not going to be in descending order. Standard form, it needs to be. So when I fully expand, I'll get my 4x squared term next, then my minus x, then my minus 1. And that gold expression now is in the best form. Notice my x's are in descending order. Nice. Okay, what I want you guys to take away from problem B is you pick the order that's best to multiply in. Don't just take the order that's given. You can make things easier on yourself by recognizing what you have as options when we multiply. Okay, I want you to zero in on problem C now, because problem C is going to be the first time where I would argue to you, we have some bed mass situations. We have multiple operations. So I want to work my way through C, and all I'm going to do is just box in the rest of A and B just so we don't get distracted, and I'm going to move that up on our screen. Okay, I would like to highlight a couple things to you. Just some stuff in that expression where we need to recognize our bed mass. Up above, we should be able to see that we've got 9 times that bracket. We have a squared on the first bracket. We have a subtraction between the two terms. We then have another multiply between the 4 and the bracket, and we have another squared. We've got a lot of different operations. It's okay, take your time, just follow bed mass. So of all those operations that I see circled in the original equation or my multiplications, we should be good that we have to do the exponent first. So I'm going to show some patience and some understanding of bed mass that I've got to leave that multiplied by 9 out in front. Okay, I can now expand that perfect square. Here's a chance for me to show I know that process. I'm going to square the first term, multiply it together and double it to get the middle term, square to get the last. There, I just expanded my x minus 1 all squared. Okay, now I have to go through and I have to not touch that minus 4 because I still have to do that other squared, my other exponent. So I can expand my brackets, square the first, multiply them together, double it, square the last, and I just addressed both of my squareds. Those are gone. Okay. Now I take a look at the operations I have left, and I'm hoping that this is now actually a breeze, that you guys can see your 2 multiplies in there. And so pretty quickly, we could go through and say, you know what, I'm just going to multiply in my 9 in my first bracket, and then expand in my negative 4 in my next bracket, and I can get all of my multiplication taken care of. The only thing left to do now, collect like terms. And if we put together our x squared terms, put together our single x terms, put together our constant, then I'm hoping we got down to 5x squared minus 26x plus 5, and I think that that is telling you you have, or giving you some really good feedback that you have a good understanding of today's topic. Okay, all I want to do is shrink that whole screen down a little bit, just so we can see everything. I hope when you take a look at problem 4, you can see those are some doozies for us. Your job now, jump in and get practice. Make sure that you are good to expand a perfect square binomial. Make sure you're good to expand conjugates and get a difference of squares. And then your challenge is to be able to work into what you see on the screen, being really flexible with being able to multiply things other than binomials, being able to examine multiplying in the order that best suits you. And then in problem C, you see we got some bed mass and we're good. Okay? Jump in, get some practice. Best of luck.